Good morning everyone. In this topic we have to see the limit state of collapse of Flexure. Myself Dr. Sakai Ruben, Rosaren Head, Department of Civil Engineering, Rohini College of Engineering and Technology. So every method has a certain few assumptions, whatever we consider. So that particular equation or method is based on some of the few assumptions. So it is true for any experimental setup also. So whenever you are making any setup which we will consider, that any real life problem, that also we make certain kind of assumption and it will be automatically will come. When we shall consider that problem, so what are those assumptions? The assumption here, we shall consider the assumption that plane section normal to the axis remain plane after bending. The maximum strain in the concrete at the outermost compression fiber is taken as 0.0035. The strain is 0.0035, that is the maximum limiting strain in concrete that we shall consider, that is 0.0035. The tensile strength of the concrete is ignored. So that is almost we can say primary assumption is our concrete design. The reinforced concrete design, we are assuming that we shall not consider tensile strength of the concrete. The stress block may be assumed to be a rectangle. What is a stress block? The stress block may be assumed to be a rectangle trapezoid parabola or any other shape, which result in prediction of strength is substantial agreement with the result of testers. So even if we consider a beam, and that beam, if you test it, whatever the failure load you are getting, and whether with your model whether getting that result, then you can say that it is in a good agreement with the experimental result. And the method you have proposed, the stress block that you have proposed, that is valid. The next assumption, the stress in the reinforcement are derived from the respective stress strain curve for the type of the steel used. So the stress strain curve for steel, that also you have to consider. For the design purpose, the partial safety factor gamma m, that is the material, that partial safety factor steel we consider normally 1.15. So if Fi is the stress, that is a yield stress, so we have to consider Fi by 1.15. that you have to consider, that is the for a design purpose we shall consider, we never take the ultimate limit for our design calculation. The maximum strain in the tension reinforcement in the section at failure shall not be less than Fy divided by 1.15 Es plus 0.002. So Fy divided by 1.15 Es plus 0.002. This is the strain that should not be less than this value. So for a different grade of steel, we shall get different limiting strength. Normally we have three types of steel: Fe250, Fe415 and Fe500. Most of the cases we use Fe415, and mild steel we use it as Fe250. According to IS 456, this is your stress strain curve for plain concrete. What we consider here, please note the strain. There are two strain. One is 0.05, which I have already told, which is specified in the assumption given in IS 456 2000. So that you should remember that 0.0035, that is the limiting strain. The maximum strain is allowed in concrete or plain concrete. For the design purpose, we shall use this curve. We shall take 0.67, that means 2/3 of the cube strength or characteristic strength we shall consider for our design purpose. Further, we shall consider this value, that is 0.67 FCK divided by gamma m, that is a partial safety factor for material. Gamma m for concrete we consider as 1.5, gamma m for steel we consider as 1.15. It is justified because we are considering, we take the steel that is manufactured in workshop for a controlled environment. So obviously we can take a less value, but in a concrete it is made in the field, so we are taking little bit higher, that is 1 for steel, then 1.5 for concrete. Thank you.